welcome to your first set of Chemistry 1 video notes. Today we're going to learn about the following standards, which involve the states of matter, state changes, and thermal energy. Before we start, here are some vocab terms that you definitely want to write down in your notes. When we talk about the states of matter, we can talk about them on the microscopic scale or the macroscopic scale. In other words, we can talk about their particles, or the microscopic scale, or we can talk about them just as a substance as a whole, the macroscopic scale. So let's look at them microscopically first. We learned about this in our demonstration yesterday, but the particles of solids, liquids, and gases are different when we talk about how close they are together. In solids, the particles are very close together, which makes compressing them near impossible. The particles of a liquid are also fairly close together, which makes them a little easier to compress, but not much. And as you can see, the gas particles are very far apart. In fact, that's one of the basic assumptions to our kinetic theory of gases, which we'll learn about later. That assumption is that the distance between gas particles is huge in comparison to the size of each particle. We can also talk about how the particles move. So in a solid, these particles stay in the same spot, but they can vibrate around fixed positions. This is why a solid holds its shape. In a liquid, those particles are able to move past each other, so they fill up the bottom of whatever container they're in. And gases are constantly moving in very quickly. They move past each other, and they also collide with each other and the walls of the container, which is where we get pressure, but that's a lesson for another day. Gases will fill up the entire container that they exist in. On the macroscopic scale, solids have a volume that remains constant. They also have a shape that remains constant. Liquids change their shape, but their volume stays the same. And then gases don't have a constant volume or a constant shape. You're probably aware of the melting and boiling points for water, but did you know that every substance has a melting and boiling point? When that substance exists at a temperature that is less than the melting point, it exists as a solid. When it has a temperature above the melting point, but below the boiling point, it's a liquid. And when that substance exists at a temperature higher than its boiling point, it's a gas. Well, you might ask, why is there a specific temperature at which these substances exist in different states? Well, when we think back to yesterday's demonstration and how we learned that the particles of a substance move at higher speeds when they have more thermal energy, we can really make sense of it all. All particles in a substance have a certain amount of intermolecular forces that hold them together. Basically, the particles like to buddy up together and stick together. We call these forces the forces of attraction. The forces of attraction remain constant for a single substance. As we increase the thermal energy of that substance, or we heat it up, we can start to overcome those forces of attraction and allow the particles to move away from each other. So, in a solid, there's just not enough thermal energy for those particles to overcome the forces of attraction. That's why the particles of a solid stick together. As we heat up the substance, we have more thermal energy. Once we get close to the temperature in which the thermal energy is equal to the forces of attraction, the particles will still stick together, but they're able to slide around and move past each other. That's the point in which we have a liquid. Finally, as we heat up that liquid and it begins to boil, those particles gain so much thermal energy that the forces of attraction are minimal in comparison. This allows the particles to move very quickly and not get stuck together. They just bounce off each other, which is why a gas takes up the whole shape of the container it's in. There are 6 state changes, or phase changes. Those terms are interchangeable. As we go from solids to liquids to gases, we increase the amount of thermal energy that the particles have. Make sure you write these 6 phase changes in your notes and know which ones go to which. So from a solid to a liquid, that's melting, but from a liquid to a solid, that's freezing. From a liquid to a gas, that is evaporation. And from a gas to a liquid, that's condensation. And the 2 tricky ones, since you didn't already learn about them when we learned about the water cycle in 8th grade, are sublimation and deposition. So sublimation is from a solid to a gas, and then deposition is from a gas directly to a solid. It skips the liquid state altogether. I remember deposition because of frost. So in the morning, when you usually have dew, if it's cold enough, it takes the water molecules from the air and deposits them on your grass in your yard as ice or frost. Make sure you write those phase changes down in your notes so you can look back at what they're called. Well, that's all I have for today, folks. I hope that you learned what you need to learn about standards C.1.5 and C.6.1. As always, if you have any questions, let me know.